All right, good day. Currently, it is 10 p.m. Right. So for this video, right, our goal is to get you guys up to speed with our final part for IETHERM, which will be about heat transfer. Right. You might think to yourself, okay, now heat transfer may be, or it might have the same connotation as thermodynamics, right? We learned that in the first part of IE Therm. Doon nga nakapangalan ang ating subject. But for now, heat transfer, I want to clarify to be different from thermodynamics in the sense that in thermodynamics, we learn. Oh, hello, Cole. We learn to study, right, the different ways in which energy is transferred, right? In the different ways as well that energy is stored, right? In this case, there are two possible ways that energy can be transferred, which is yung una, yung work, and then the other one, which is heat. The only problem with heat is that it's usually not something that we care about in the sense that it's something that we can measure, right? As with work kasi has a formula, right? Usually we follow work non-flow in our case, in our discussion, right? That is going to be P2V2 minus P1V1 all over 1 minus n. Ito ang ating general formula. The formula might change depending on the kind of process available, but, well, here we are, right? Yung heat naman, letter Q, usually we don't care so much about it in the sense that, well, Q, alam na natin from high school to be MCAT, right? But that is it, right? In the sense, what we're doing with Q in here is that we are just trying to describe how much heat has been passed or how much heat has been transferred. But it's not as simple as this, right? It's not as simple as this. You guys will learn in your EngFis, right? In your EngFis subject that there's what we call calorimetry, the measure, right? The study of the measure of how much energy something has, right? Makikita nyo there are different kinds of heat out there. But for now, what we'll be doing lang is we'll be focusing on the very classic, on the very classic of heat transfer, which is how is heat transferred, right? Because, well, it's just simply way more than this, okay? How heat is transferred, right? Ito ang magiging focus natin for today's topic, right? And basically, yan, heat transfer can be measured, or rather can be heat can be transferred in three different ways. Of course, we know this to be conduction, convection, and radiation, right? Conduction, convection, and then, not convention, convection, and radiation. Okay? Now, before we begin with the formulas and everything, the computation, blah, 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 right, we should acknowledge what these guys are, or what these processes are, how they occur microscopically or molecular level. And, well, kung ano yung magiging formula niya later down the line. Later pa yun. Right? For now, what we want is a more conceptual kind of discussion wherein we start off with conduction, of course, right? This is what we normally feel when we're talking about heat transfer. More specifically, for example, when we are touching something really cold or something really hot. Like, for example, yung hot plate ng mga oven or ng mga stove. That's why we don't touch it, because what happens is that our skin, or rather our material, our flesh, comes into contact with hot material. And as you might notice, what is the commonality between the two? Both of them are going to be solids, right? For all intents and purposes, solids transfer heat differently compared to, well, fluids, right? So makikita na natin that conduction is mainly the mode of heat transfer, right? This is modes of heat transfer. Modes of heat transfer, right? That is afforded by solids. When two solids come into contact, kumbaga, what happens is that they pass heat. The hotter one, right, passes heat to the colder one. Oh my goodness. The hotter one passes heat to the colder one. So, magiging flow ng heat natin will be like this. Right? So, ito yung ating Q. And what happens is that you might think now, for us to build the formula, which is called Fourier's law, right? Which is called Fourier's law, we need to think about what the different factors, excuse me, that come into play for us to say that we are transferring more heat, right? In fact, doon galing ang ating law, right? There are going to be 1, 2, 3, and then 4, right? 4 things that we need to see or that we need to observe first before we get here. And uunahan ko na kayo, right? You might want to notice, right? You might want to notice that for here, right? Uunahan ko na kayo in that sasabihin ko na more heat is transferred the higher the temperature difference is between the two surfaces, right? The higher the higher the temperature difference, the higher the heat is transferred. Kumbaga, let's clarify this example. Let's say, for example, that we have here a block of material, right? Let's say here we have a block of material. And then on one side, this block is exposed to something that is really, really hot, right? Something that is really, really hot, right? Something that is really hot. And on the other side, something that is much colder, right? Something that is much colder. I'll tell you for certain that kapag mas malaki ang temperature difference nitong dalawa, the greater the heat transfer will occur. Kumbaga, mas mataas yung number, right? So, that will be the first part of our formula. The first part will be temperature difference, delta T, right? The higher the temperature difference, the bigger the heat transferred via conduction, right? So, temperature difference. Next, what else do we think here? Right? Let's say, for example, let's have a little thought experiment, right? Let's say we have this piece of material, then we know that. And then instead of having the same, with them having the same temperature, what if, right? Yung same temperature gawin natin na sobrang liit lang ng kanyang pagkaka-contact, right? Let's say it only contacts this region, right? And let's say, for example, also that the blue, or rather the cold section, is only also smaller. So what do you guys think will happen to the amount of heat that is transferred? Kung itong dalawa lang na ito, na area ang magko-contact sa ating conductive surface, of course, right? The number, right? The amount of heat that was transferred will decrease, which leads us to a second part of our equation, which is going to be area. The area that was the contact area. Sabihin na lang natin, right? The contact area. Contact area. Next, right? Next, what we will have is something specific to the material itself. Hopefully, you guys can notice that hindi ako nagbabanggit ng name ng material. It's just some material, right? It's just that, let's say, for example, if this was concrete, right? If this were concrete, magkataka kayo na parang konti lang naman yung heat na mata-transfer, right? Even if magka-contact nga itong si hot plate, itong si cement or si concrete, and then itong si cold plate, sabihin na natin, right? There's not going to be a lot of heat transferred. However, ibang usapan na yan kapag metal, right? Metals are known to be thermally conductive. And now this is where that kind of material difference is going to be important, right? Different materials have different what we call thermal conductivities. Yun ang tawag sa kanya. Letter K is how we would denote this, right? Thermal conductivity. Thermal conductivity. And then, right? Finally, the last piece to our equation in here would be something, right? Would be something that is now parang reciprocal. Reciprocal in the sense that kapag lumaki itong value na ito, liliit ang ating heat transfer. And hopefully you guys can see, or rather you can think about it, try and give it a go, right? Pause. Ano kaya dapat na ganun? Right? Now, okay, if you've unpaused, right? Let's say for example na ganito na yung itsura ng ating material, right? The material has not changed particularly, right? Pero what has changed, hopefully you guys can notice what has changed, is the length or the thickness of the material wherein the heat has to quote-unquote pass through. Right? Ayan. Okay? So now we can see in here that there's going to be less heat transferred. Kasi Diyos ko, alayo ng lalakarin ng heat, quote-unquote. Right? This one naman, very, lots of heat is being transferred here because it's not a lot of thickness that it has to go through. Now, the last part here would be what we call delta X, right? The length, or rather the distance between the two conductive surfaces. Okay? So finally, our equation for determining the amount of heat transferred via conduction is complete. This is Fourier's law, and basically this states that the amount of heat conducted is equal to K, the thermal conductivity, times the area, the contact area, right? Times the temperature difference all over the thickness, right? Yun na lang sabihin natin, the thickness of the material. Okay? This is why frying pans get so hot. Sabihin na lang natin, right? Number one, a frying pan has a lot of thermal, is made of metal usually, so it has a lot of thermal conductivity, right? Contact area, magtataka kayo, anong contact area niyan? If you're going to think about it, right, the pan, now, if for example, ang gagawin ko na lang na example is yung hot plate, right? Not a stove, a gas fire stove, kasi iba na yun. I feel like that's more convection than anything, right? Pero if it's on a hot plate, right, what's currently happening is that there is a lot of contact between the hot plate and the cooking pan, such that, ayun, doon magta-transfer yung heat times the temperature difference, right? What is the temperature of the hot plate? And what is now the temperature of the initial temperature of the pan, right? And then last would be, ito nga, yung thickness, right? The thickness of a frying pan or of any kind of cookware is relatively thinner than, well, most materials that you would see for construction, sabihin na lang natin, concrete or glass or wood, right? Kaya mataas talaga by default ang magiging heat, right? Heat transferred via conduction kapag ganito. Okay? That is Fourier's law. Okay? So let's give that a quick summary in here. Right? Quick summary lang. For conduction, we have Q cond is equal to K. Actually, K can be written down sa baba, and then A as well. And then delta T over delta X is usually written down like this. Right? That is now your Fourier's law. Okay, now, the next one will be convection. Makikita nyo, actually, let me just give it a little search. Kasi hindi ko alam kung ano dapat yung totoong pangalan ng convection formula, if there is anything. Kasi yung heat conduction, yeah, parang wala naman, honestly. Yeah, but what, Black's equation? Yeah, I'm not seeing anything in here. Okay, so then, right, what we're just going to think about is just the convection equation, right? And this one is going to be a little bit more simple. Oh, before I forget, the units for all of these, right? The units for all of these. Let's first start with area. Alam naman natin ang area. That's going to be meters squared. Ang ating temperature difference is going to be in degrees Celsius or pwede yang Kelvin. Right? And then, itong sa, anong tayo ito? Anong thickness will be in meter. And then, itong ating thermal conductivity will be in watt per meter, either Kelvin or degrees Celsius. Right? For this purpose, for only this purpose, only for heat transfer purposes, anything to do with a temperature difference, magiging interchangeable ang ating Kelvin and degrees Celsius. Okay? Just so we understand, right? Kelvin cancel, dalawang M sa ilalim, and then dalawang M sa taas. We will be left with, of course, watts, which is the same unit that we need for heat transfer. Okay? Now, for convection, punta naman tayong convection. Let's say, for example, convection, we have something here, and then, let's say, for example, na, I don't know, is this the hot thing, or should this be, okay, let's sabihin natin, this is the hot thing, right? This is now your hot space, and what will basically happen after this will be, there will be some fluid that is flowing over the hot thing, right? Let's say, for example, that this fluid is going to be a bit colder than the hot parang plate, sabihin na lang natin. And because of the flow of the molecules here, what will happen is that these parang this fluid motion can actually transfer heat away from the hot plate. This is the core of convection. Convection has something to do with the use of fluids to transfer heat, right? And so now, we will have another parang formula here, although now I don't know who to attribute it to, right? There will be three kinds, or rather three factors, again, for heat convection. Hopefully, you guys can try to figure it out, right? Let me just take a sip of water. Hold on. Okay. Now, if you've paused, give it a thought, right? Unahin muna natin, of course, the same thing happens, right? With conduction, convection, radiation, all of them depend on the temperature difference. More, right? More heat will be transferred the hotter or the higher the temperature difference is. So very, ano tayo dito? Very self-explanatory here. Temperature difference. The thing kasi is that heat will not transfer, let's say for example, from one place to another if both of them have the same temperature. Right? Let's say for example, pareho nga silang 35, edi wala magta-transfer dito. If for example, you want it to be, let's say for example, 36, what will happen is that it will very slowly, right, transfer heat until both of them become a certain temperature. Right? And then let's say for example, sobrang tataas nito, let's say for example like something like, I don't know, 76. Of course, there's going to be a lot of heat transferred between these two. Right? Now let's go back. Of course, there will be temperature difference, and of course, the same thing will happen as last time. If we imagine that a lot of the fluid is being in contact, is contacting the hot plate, of course, there's going to be more where the fluid can pass. Where the fluid or where the hot plate can transfer heat to the fluid. So ibig sabihin, of course, another kind of thing or factor in here would be the area, the contact area once again. And now, the final one, I feel like this might be the hardest one to spot, would be the behavior of the fluid. Right? Not only the behavior of the fluid, but its general parang properties. Right? Not only the behavior of the fluid, we are talking about things like, let's say, for example, density. If a fluid is more dense, chances are, right, it has more mass so that you can transfer more energy to it so that it can take away more energy. So this is why air drying is gonna be less intensive than water cooling. Kumbaga, air cooling, right, is less effective than water cooling because literally you're passing by water which has a lot of stuff in it, right? because it's quite dense, right? All of those particles, kumbaga, can contribute more in transferring energy away from this hot plate compared to just air cooling, right? And all of these values, all of these parang circumstances are summarized into letter H, the convection coefficient, right? Here we can also think about it as the film coefficient. You might be wondering why it's called the film coefficient. In this case kasi, what happens is that I don't want to get into too many details because, well, that's above your guys' jurisdiction. Di na natin yun kailangan matutunan. But in this case kasi, right, what happens is that at some point, the fluid will develop what we call a thermal boundary, or this is the thermal layer wherein convection is bound to occur, right? Everything else hindi to counted, kumbaga, right? This one is where you can see actually the relationship between conduction and convection coming through. And again, like I don't want to get into too many details here, but that is why it's called the film, because kumbaga, it's like a film of fluid is enveloping the solid in here, is enveloping the thing that you want to remove heat from para yun yung mag-transfer ng heat. Okay? And not only are we talking about the general properties of a material such as, let's say, for example, its density, its viscosity. There are also other things, like for example, well, ano tayo ito? For example, the way that the fluid moves. We can say that, hold on. Okay, sorry. We can say that actually there are two different kinds of convection based on the behavior of the fluid. Based on the behavior, we can think about it as number one, natural convection, and number two, forced convection. Hopefully, you guys can immediately detect what is the difference between the two. For natural convection, the fluid moves freely. Kumbaga, it's just, it's just air flowing over a field or something like that. Pero kapag forced, now, you're involving machinery to induce the flow of air. Let's say, for example, the flow of fluid. This is why, even though it's hot outside, right, if it's windy enough, we don't feel hot. Kumbaga, the air, because it's so fast, it's running by us so quickly, what is happening is that it's taking away heat from us, even though medyo mainit pa rin actually. Right? Yeah. And that is why also at night, or basta anywhere that it's very windy, it tends to be also pretty cold. This is what we call wind chill. Right? Wind chill. And this is kumbaga because of such high air velocities or just high air speeds, what happens is that this film coefficient actually increases. It is now able to, the air is now able to receive heat more because it's going by you faster. So ayan ang ating convection heat transfer. Right? And finally, our radiation heat transfer. Ito yung pinaka parang komplikado. So let's just rewrite this again here. Not convection, convection. Convection. We will have Q convection is equal to H bar A and then delta T. So you might be wondering, okay, saan ako kukuha ng H bar? Ako ang magbibigay. Right? Ako ang magbibigay. If hindi nyo alam pala rin kung saan nahanap ng letter K, baka hindi ko ibigay. Because nasa tables nyo. Right? If you're going to look at table, A21, I think, or A19, say for example, let's go on A19. Ito, we have properties of selected solids and liquids. Right? Here we have thermal conductivity. It's actually written here as the letter K, kappa. Right? The Greek letter kappa. So hindi nyo makikita ng letter K like this. It's actually letter K like this. Pero, well, wala naman tayong ginagamit na ibang K. Well, actually meron. Which is the adiabatic index, but I don't discuss that with you guys a lot. But anyway, nandito ang ating thermal conductivity. Right? So let's say for example, magsabi ako na, okay, we're talking about aluminum, through conduction, edi, ito ang inyong thermal conductivity. Right? So, something like that. So, makikita nyo, some of them are very conductive, thermally conductive. A lot of them as well are not very, look at this, insulating materials. Kaya nga sila insulators because, well, mababa ang kanilang thermal conductivity, aka they are not good at thermal conduction. Right? Hopefully that is clear enough. Okay? Actually, water, if we think about it pala, water here as well is not that great at conducting water. More so siguro if you use it in terms of convection, dun pa mas maganda. But now we're here, right? Convection, nakatapos lang natin. And the units for convection are as follows. Yung A, syempre, naka m squared pa rin yan. Yung delta T, either that's in degrees Celsius or it's going to be in Kelvin. And now this one, our film coefficient is going to be, right, is going to be watt per meter squared Kelvin or, right, or degrees Celsius. Again, these two only for heat transfer. Only for heat transfer, those two are the same. They are interchangeable. So now, tapos na tayo I just realized I'm using a very Filipino palette right here. But anyway, since tapos na tayo sa ating convection and conduction, we will now move on to our last part, which is radiation. Right? Radiation, I feel, is the least, what do you call this? Least natural or least intuitive kind of mode of heat transfer, but still, right? It's very important in that, well, it's what allows the Earth to receive energy. It's what allows the Earth to receive heat, even though, right, if you think about it, the Earth is kind of isolated, right? Ang nangyayari sa Earth is we are just a floating rock in space. Tapos ang mangyayari lang is that we have, my green, and we have the sun to thank for, right? To thank for our energy. What happens is that even though the vacuum of space, in the vacuum of space, there is no fluid, there is no solid, there's nothing, literally nothing between us and the sun's energy can still go to Earth and pass by us because of radiation. The thing about the sun is that it can do this because it is so hot, right? So hot in the sense that now, pupunta na tayo sa ating heat transferred via radiation. We will now attribute this to Stefan and Boltzmann for our law. I think Stefan nga lang minsan right? Stefan Boltzmann law. Right? So now we will have this, and actually in here you will have 1, 2, 3, and then 4. Right? 4 na naman. Actually, the first one here is a bit a bit of cheating. I will now reveal it to be, right, the Stefan Boltzmann constant. The Stefan Boltzmann constant basically is this. Stefan Boltzmann constant. And basically, the Stefan Boltzmann constant is very small. 5.67 times 10 raised to negative 8. Now, this is sigma is equal to 5.67 times 10 raised to negative 8 all over watt per meter squared Kelvin raised to 4. So you're like, what? Huh? Right? Don't worry about the units for now. Just think about the magnitude of this number. It is exceedingly small. Right? It's exceedingly small because, well, makikita nyo later down the line. But for now, the one that we always talk about kapag nag-heat transfer tayo either via, conduction or convection, still holds true, but there's gonna be a little bit of a modification. Let's say, unahin na muna natin yung area, of course. Area. Right? The more area that is exposed to radiation, the more heat that we can accumulate. Yan ang ating contact area. Right? Very easy to understand again. It's very intuitive, hopefully. Next will be, yun ang sinasabi natin, yung temperature change. But in this case, I am not talking about temperature change. I'm talking about the temperature reading. And not only am I talking about the temperature reading, I'm talking about the temperature reading raised to 4. This is why the Stefan Boltzmann constant is this all over Kelvin raised to 4. This is not degrees Celsius raised to 4. This is Kelvin raised to 4. Right? If you're gonna ask me, I don't know, ang nangyari here was that si Stefan and si Boltzmann, what they chanced across was that when they were trying to curve, right, to fit the curves of radiation heat transfer, ang lumabas was that it scales to a power of 4. Right? It scales to the temperature to a power of 4. So, ibig sabihin, let's say for example, even I am emitting, right? Even I am emitting radiation, right? Not only am I warmer than the air, which leads me to convect heat away from myself, ang nangyayari din is that I am also radiating heat. More specifically, I'm radiating infrared, right? Tama. I am, what do you call this? I'm radiating infrared radiation, kumbaga, right? And so, of course, that's not very powerful, but still, I am capable of, and I feel any object, almost any object, so long as you have a temperature reading, is available in emitting radiation, right? It's just not gonna be a lot, kumbaga, right? The last one, before I just try doing it to myself, will be this one. And again, it feels like a bit of cheating, but in this case, we will talk about emissivity. Emissivity. Of course, now, we are talking here about contact area. Tapusin na lang natin. Area. And now, in here, we are talking about temperature reading. So, kailangan very particular tayo. Temperature reading, not just temperature difference. Right? So, in here, I want to say, note, only Kelvin, not degrees Celsius. In here, they are not interchangeable. And the last one here would be something that we call emissivity. From the word itself, so sana may hula kayo as to what the word means. Emissivity is a measure of how well an object can emit heat. Right? Emissivity. How well can this object emit heat or radiate heat? Radiate heat. Right? And so, this will only be from a scale of 0 to 100%. Right? Aabot lang siya from 0 all the way to 100%. Now, if the emissivity of an object is 0%, which is very parang difficult, I suppose, to achieve or to look out for, because nothing is an absolute, right? Almost everything will have an emissivity. Ang mangyayari is that you call it a white body. White body. And then, something that can emit 100% available heat through radiation would be what we call, of course, a black body. And what do you guys guess would be the thing in between? Because napaka-creative ng mga scientists, it would be a gray body. Right? So in this case, ganyan ang ating emissivity. This is why, and black does not just mean here just some arbitrary color. This is actually informed by, right? This is informed by actual science. Like, let's say for example, kapag lumabas ka, tapos super init, what will happen is, well, mas maiinitan ka if you're wearing black. Hopefully, you guys have parang seen this in action with yourselves, right? Mas maiinitan kayo kapag lumabas tapos mainit, tapos nakaitim pa kayo. Kaya ang sinasabi, ang recommendation kapag summer is that you wear light-colored clothes. Because what will happen is that you will not only emit less heat, but you will also absorb less heat. Kaya minsan, ang ginagawa is that the kind of emissivity, the amount of emissivity, should also be the amount of what we call absorptivity. Hopefully, again, you guys can see what this means. How well can this object absorb heat? Oh my goodness. Absorb heat, right? So if a black body can emit 100% of heat, that can also mean that this is a double-edged sword and that it can also absorb the most amount of heat. Okay? Yun ang ating difference, or rather yun yung ating Stefan Boltzmann law, the very simplified version of it, because actually meron pang mga nakalagay pang extra na terms after this. Things like view factor, but for now, let's just teach you the basics. So now we have all three. We have conduction, convection, and finally, we will have here radiation. Right? We will have here radiation. We'll have Q rad is equal to, yan. Oops, mali. T4. Right? We will have, again, our Stefan Boltzmann constant, right? Our emissivity, our area or contact area, or hindi nga contact kasi nga hindi naman sila nagko-contact. It's basta the emission area, right? Kung ano yung exposed sa radiation, yun yung makakatanggap ng heat transfer. And now, of course, our temperature reading, not just temperature difference. And again, let's try this out. We will have meters squared. We will have kilogram tuloy. We will have ang tawag dito, Kelvin raised to 4. This is unitless, right? This is unitless. And then finally, this one is yung 5.67 times 10 raised to 5.67 times 10 raised to negative 8 watt per meter squared Kelvin raised to 4. So which you can see, cancel. We will have naka-watts tayo, right? Same as before with here. Cancel. May matitira sa atin na watts, right? So yun. That means that all three of these are the parang classical modes of heat transfer, right? These are the ways in which we can experience the heat being transferred all around us. Let's say, for example, I'm being very parang nitpicky here. Currently, I'm recording while the window is open, right? And of course, it's raining outside. So, ang mangyayari is that there's going to be, right, convection all around me, right? The temperature of the air is much lower now than normal because of, well, the rain, making everything just a little bit colder. And because of my body temperature being higher, significantly higher than the air temperature, syempre, what will happen is my body will transfer heat from myself to my surroundings. How that can work is, for example, I'm leaning on my table, right? I'm putting my arms on the table, and what's happening is that my arms, my hands, right? Anything that touches anything else, my butt to the chair, right? What's happening is that it's transferring heat through conduction. These guys, or basta these pairs of objects are touching, right? And what's happening is that when they're touching, the molecules, kumbaga, are bumping into each other because they're excited, because they're hot. They'll bump into each other, and then those molecules will become hot. Those molecules will then have passed their heat. Next, right? Of course, yun na nga, yung air around me is a fluid, and based on, let's say for example, pag wala akong electric fan, everything is natural. The breeze will take care of it, right? Kung mainitan man ako, that's my fault because di ako nag-electric fan, right? Natural convection entails that not a lot of heat transfer will be done, right? And because not a lot of heat transfer is done, you or me or I would feel just a little bit more warm because, well, hindi pala ako nawawalan ng heat. Kumbaga, the heat is continually being just surrounding me, right? Just being around me. And if buksan ko yung electric fan, of course, maririnig nyo, right? But if buksan ko yung electric fan, I am now forcing the air, right, to move in such a way that it's now faster, right? This has more velocity, and what happens is that more air particles, air molecules, right, the molecules of nitrogen gas and oxygen gas in the air are basically flying by me, transferring heat away from my body. And again, ito na yung radiation natin. The current, the common emissivity daw of a person is 0.95, is 0.95, yun, as a number. So 95%. We are a 95% black body. Let's just see, for example, kung ano yung magiging amount of radiation ko. Let's say, for example, we have, yun nga ang ating Stefan Boltzmann constant, 5.67 times 10 raised to negative 8 watts per meter squared Kelvin 4 times our emissivity daw, which is 0.95. Our area, I think our common surface area is what, like 2 square meters ata. Let's say, for example, 1.8. I forgot the common example here. And then my temperature. Currently, my temperature, I don't know, is about 37 degrees Celsius yan. So to turn it into Kelvin, you need to add it to 273.15, and now it's in Kelvin, and we raise that to 4. Cancel, 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 cancel. We will now just have the numbers all in watts. 5.67 times 10 raised to negative 8 times 0.95 times 1.8 times, ano ba ito? 37 to 13. This will be 310. Ba? Yeah, 310.15 raised to 4. Let's try that out now with my calculator. 5.67 times 10 raised to negative 8 times 0.95 times 1.8 times basta 27 plus 273.15 raised to 4. This will give us 786.923 watts. Right? Yeah. Parang ang laki. Let me just search the common surface area of a human being. Surface area of a human being. The common one would be, ayun, 1.5 and 2 square meters. Okay. So, ganun nga talaga ang mangyayari. Okay? So, this is the amount of heat that I'm transferring to my surroundings via radiation. Okay? So, because, right, this is gonna be raised to 4. This is gonna be a really big number. But, right, ang buti na nga lang talaga is that the Stefan Boltzmann constant is quite small as well. Right? So, dun manggagaling ang ating, kumaga parang ang ating control. Right? But anyway, that is very, very basically how to use the 3 modes, or this is how to think about and how to use the 3 modes of heat transfer. Conduction for solids, convection for liquids or fluids in general, and radiation for basically anything that has temperature. Okay? So in the next video, we'll talk about how to actually compute these things. And syempre, because of these formulas, they should be somewhat straightforward. And yun na nga lang talaga, ang gagawin na lang natin is let's try to discern the kinds of temperature differences, the kinds of contact area, surface area, and how to find thermal conductivities in our next video. So yun, thank you very much for your attention. I will see you in the next one.